So let's see some interview-based questions. What happens? So let's say you will find this question everywhere. Everywhere it is asked. So first, parentheses, it will contain 6 characters. Okay. First, anyway, the name we won't be discussing, but just for clarity, if you don't think that you can write in the stack data structure, try to write in the name field structure. I just wanted to see whether you are able to think in the correct direction or not. This is the idea of how we solve this code. Now let us write the code for it. So we'll just have something like this. Stack dot is empty. So guys, please have a look at this diagram. Says whether the stack is empty or not. It is empty, so we'll return a true. So let's see some interview-based questions. The one of the very popular questions, although it will come under medium category, but we can see in every interview is the balanced parenthesis. What happens? So let's say you will find this question everywhere. Everywhere it is asked. One of the very popular question on stack, balanced parenthesis. You guys, as the name suggests, parenthesis you already know. But just for simplification, what it should be is, let's say you have an input, something like this. So first balanced parenthesis, it will contain 6 characters. Okay, first before writing the input output, let's see what balanced parenthesis actually contains. It contains 6 characters. Okay, what can be those 6? These two. These are also the part of these 6 characters. These 2 characters, then these 2 characters, and at the end these 2 characters. Small bracket, big bracket, and curly bracket. These are the part of balanced parenthesis. These are the only 6 characters which will be given in the input. You are restricted that these will be the 6 characters being given as an input. Now you have to find whether the input given is balanced or not. What do you mean by balanced? So let's see here. Let's say your input is something like this. There's a big bracket, then a small bracket, then again a small closing bracket, then a big bracket. If you see what should be the output of this, the output of this is yes, it is balanced. So it will be true. But if you see, if you interchange this in this way, like if we take this and we take this, but we close the bigger one first and the smaller one last, so it is a false. It is not balanced. If you see, we have the big bracket, then small bracket, then initially the small bracket should close first, correct? If you see in the figure itself, it will show you non-balanced. Okay, this can be one example. Another example can be something like this. I'm just modifying this. So say, let's say this is there, then this is there, then you just have this thing, correct? So if you see, this is also not balanced. Why? Because see, this closing bracket is fine. You open it, you close it, but what about this big bracket? It was not closed. So again, this is non-balanced. What else we can think? Let's try all these three. So let's say we have this, we have this, we have this, then we have this, then this, then this. Obviously, it's balanced. Then again we have this. Again a false. Why? Because see, we have 3 opening. Order is also preserving. For the curly bracket close, then small, then the big bracket. But at the end, there is one more curly bracket closing. But there is no opening for this outside curly bracket. So again, it will be a false. So when how it can be true? Let's say if we don't have this last one, then the output of this will be a true. Okay. So this is what is the balanced parenthesis. So this is your question. Please start solving it. Try. So how you can solve it is try to do 2 things. Either try to use a stack. By stack, what you can do? You know how to push. You know how to pop. Correct. Try to push. Try to pop, and try to figure out how you can find that the string is balanced or not. Second thing, what I want from everyone, even though stack is new, correct? I understand that you cannot write the code in the very first go, but you guys should try to write the code in the name approach as well. Anyway, the name approach we won't be discussing, but just for clarity, if you don't think that you can write in the stack data structure, try to write in the name field structure. I just wanted to see whether you are able to think in the correct direction or not. Let us see what is the idea. So, see how we'll break down this question. Every time in the stack operations, how will you know whether it is balanced or not? Okay, is there will be typically 3 things. Basically, when you have to push, when you have to pop. Okay. So first thing is when you encounter these 3 things. Correct. These are all the openings. Whenever you encounter something like this, there is a scope that something could be there at the end. So whenever you encounter something like this, you will do stack.add. Correct. And whenever you encounter something like this, that means you need to pop. But when you need to pop, correct. Let's say if the input is something like this, if the opening is this and the closing is this, okay. Then what happens when you get the first big bracket, you put it in the stack, okay. You put in the stack now has this. Now when you encounter this, what you need to see is that whenever you encounter a curly bracket, you will have a condition that the peak of the stack should have the opening curly. Correct. So let's say you have something like this, and you have to say whether the stack is balanced or not. So when you encounter the first curly bracket, you put it in the stack, okay. You put it in the stack. When you encounter the closing curly bracket, you know that you have to do something regarding pop. But when to pop? For popping this, we need to see the peak of the stack. peak of the stack is the opening curly only, and now it is closing curly. Since both are, we can say if the closing is this closing curly and the top of the stack is opening curly, then we know what we need to do. We need to pop the element from the stack. We'll pop this. Our stack will become empty. So the whole idea is by doing all our operations, pushing, popping, and everything. So yeah, I mentioned here add, but it's still push. Okay. So the idea is by doing all the operations, either pushing, popping, or anything, our stack should not be empty. The condition check is this thing only, stack dot is empty. If it is true, that means it is balanced. If it is false, that means not balanced. Okay, pretty simple. Whatever operations you do, let's say you had something like this, 2 opening bracket, 2 small bracket, 1 curly bracket, and then you have same closing also. So what will happen? This will close out this will close out this, and this, and this, and at the end, your stack will now again become empty. Stack is empty, then it means that the entire string was balanced. That's how it was able to pop, correct? But let's say if it was something like this, and here, and then it was a here, something like this, closing first that and this. So once it encounter the first closing, and if it encounters a curly, it says no, it is not there. This closing, this is not there. Like the peak of this, when we got the first closing, we see the peak is not there. Correct. If the closing is this and the peak is this, that means these two are mismatched. And whenever there's a mismatch, you don't need to do anything because see whatever happens after this. Correct. Let us see something like this. Like it is a large bracket, a curly bracket, and a small bracket. Okay. And let's say after this we encounter a curly bracket. Let's say we encounter curly bracket. Now whatever comes after this, it doesn't matter because string has now become imbalanced. There's a mismatch. Correct. Because first the closing should be first, since it is small bracket, the closing should also be small bracket. Correct. So the order is not preserved here. So from this point itself, whenever we find a first mismatch, we return a false. This is the idea of how we solve this code. Now let us write the code for it. So let us first define a stack. Okay. Now we want to iterate our, let's say, how we are given as an input, we are given a string, correct? A string will be given, string will have everything. So let's say our input is a kind of a string. So how we want to do, we want to iterate over the string, correct? So that we get all the characters one by one. So let's write something like this. Now, what we want to take out all the elements of the string one by one as a character format. So let's write that thing. Char ch equal to s dot caret I to get all them one by one. Correct. Now we have got the strings as one by one. Now the first condition check will be when to push. Correct. When we want to push the element in the stack. So for that it will be if this ch is equal to it can be three. It can be every time it should be the opening thing only. Correct. Opening big bracket, curly bracket, or small bracket. So let's first write if it is the opening small bracket. Correct. Or anything among them, it will take opening curly bracket or ch equal to opening big bracket. This is fine, correct. Now, if it is anything like this, so what we want is that we want to push in our stack, and we have defined stack as st. So let's do st dot push. If it is anything like that, let's push that element in the stack. So we'll do st dot push ch. That element is now in our stack. Okay. Now, if it is none of these, that means we have to go under the else case. What is the else case? Else case is it is not one of these. It is not the opening. It is the closing of any of these three types, either the large bracket, small bracket, or curly bracket. But it is a closing type. That's why we got to the else case. The else case, we are looking for a pop. Okay, but we have to think like it should not be like we should not get some kind of exception. Correct. We need to check whether anything is present in the stack or not. Correct. Because let's say the very first element in the stack you get as a closing bracket. What I mean is, let's say you got something like this as an input. So stack is already empty. If you get something like this, you don't want to just take it out from the stack, right? You get some exceptions if you pop this element. Because stack is empty, you cannot pop anything. So for that checking, well, the first condition check that you will have is if the stack is already empty, correct? The stack is already empty, then just go ahead and return a false. Else if now we'll say all the else if conditions. Else if the element currently is a closing small bracket, let's say. Then what we need to see, if it is a closing small bracket, then it is the AND condition, not OR condition. Then the peak of the stack should be opening closing bracket only. Then only it will be synchronized, correct? If it if it is anything other than that. So let us write something like this because we have to find all the conditions where it should turn as false. So if the current is the closing bracket and if the peak is not opening bracket, I'm not saying equal to, but is not opening. That means this is wrong. If it is curly, if it is open, anything other than this, then it means it is wrong. Correct. So in that case, we'll just go ahead and return a false. Correct. What else? Similarly, thing we have to do for other ones also. Else if this CH equal to the closing curly bracket. Okay. And the peak is not equal to. If it is equal to curly, then it is fine. Opening curly, closing curly is fine. But if it is not equal to opening curly, if anything, it is anything else other than open curly, then it means that we need to return again a false. If it is not equal to this, if it is equal to this, then obviously it will be ignored. So it is fine. Okay. What else? One more condition is left. Correct for the big bracket. CH equal to big closing. Then if the peak is again not equal to the big opening, then again the issue. Correct. Then in that case, we'll just return the false. Correct. What else now? Now this is done. This everything is, if you see everything inside is else only. For clarity, we have given some more spaces. The what conditions are there. If already it was empty, that means there's nothing to pop. Then in that case, we didn't did anything. We just went ahead. Okay. If it is already, sorry, if it is already nothing is there, then that case we cannot pop anything. Just return a false and we say this is not a balanced state. Otherwise, if you return a closing, any kind of closing bracket, you have to check the top should be matching with this. If it is not matching, then directly return false. We don't need to add it further. Now let's talk about a case where it was the closing here, like this any of these cases. Like the closing was also the small bracket and opening was also the and the peak was also the opening bracket, the small opening bracket, the closing as well as the top. Correct. So this is synchronized. So none of these will execute. Correct. So the else now we have the final else that everything is matching. In that case only, what we'll do is that we will do the pop. We'll do stack dot pop. Correct. If you see here, this else is inside this else only. This is not outside. This else is not closed here. If everything is matching, then only will pop. And at the end, what we need to do? So this else will be closed. Correct. After that, this for loop will be closed. Now, after performing all the operations, the idea is now our stack should not have anything. Correct. Stack should not be now be empty. So we'll just have something like this. Stack dot is empty. If it is, you are coming a true out of it, then just return a true. Else return a false. Correct. So the final idea, as I mentioned, the three part of the code. So this is the final idea that our stack should finally be empty. If it is not empty, then we cannot say like whether string is balanced or not. So guys, please have a look at this diagram. So let's say we have something like this. This is a balanced string. First thing is question is clear to everyone. Anyone is having any doubt why it is true, why it is false? Let's go ahead. So okay, so this is true. Now, what happens in this loop? See, this is a string of type S. Okay, and these are the indexes. Okay, let us write it down. So index 0, you have the opening big bracket 1, 2, 3. Okay. When the value of I is 0, okay. When the value of I is 0, it is less than s dot length. S dot length will be 4. CH will be s dot character in. So CH will now be this opening bracket. Okay. Whenever you find opening bracket, you will see this condition and this it is either any of these opening, so you push in the stack. So now your stack SP has one element which is this. The opening big bracket. This else part will not execute because this else condition executed. Now we go again. The value of I now becomes 1. I now becomes 1. The CH will now be opening small bracket. If it is so, it is big bracket is small bracket. Okay. So in that case, again it is in the if condition opening, big, curly, everything opening. Then it will be the push thing. So in the stack, it will again be pushed. What is now in your stack? It has one big bracket and one small bracket. This is something in the stack. Okay. Now, at I equal to 2, what happens? The CH will be the closing small bracket. Correct. So you go to the else part. You see whether the stack is empty. No, the stack is not empty. It has these two elements. You see whether the stack closing is this thing. Yes, the closing is this thing for sure. The closing is the closing small bracket. Then is the peak the opening small bracket? This condition will be true, correct? Because see, the current CH is the closing small bracket and the peak. This is the peak, correct? The top element is again the opening small bracket. Both are matching if you see, correct? So this condition will not execute. Will go down. The CH is not this only. CH is not curly. So we don't need to check for other condition. From here only we'll go down. CH is not this only. So again, this will not be executed. Correct. So none of these three got executed. Correct. These three doesn't get executed. Let me explain again what happened. Your CH was the closing and P was also the opening. Both are small brackets only. So this condition will not execute because if the closing is a small bracket and opening is anything other than the small bracket, then means it's wrong. Everything is fine, so nothing will be executed. Here the CH is curly, CH is big bracket. None of these are true again. So again, nothing will be executed here. We go to the final else case and it says stack.pop. What happened now? It popped the first element. So after the I equal to 2, stack now has just the one element, which is the opening big bracket. We go to I equal to 3. I equal to 3, the value of CH is closing big bracket. What happens in this closing big bracket? In the stack, you will see. In the stack, you will see what? The stack, you will see that this is the big bracket closing, so the if condition will not be executed. You won't need to go to the else case. In the else case, the stack is not empty, so nothing is there. You'll go ahead again. And you'll see the closing as well as the opening. It is not a small bracket, so obviously this will not be executed. It is not a curly bracket, again, this will not be executed. It is a closing big bracket, and the opening is also the big bracket. So again, this will not be executed. This says not equal to. Again, the pop thing will happen. The else case will get executed. So stack now becomes empty. Nothing in the stack. The loop will also be ended because now the value of I becomes 4 and 4 is not less than 4. So come out of the loop in this case. It says whether the stack is empty or not. It is empty, so we'll return a true.